Good afternoon, everyone. Today we'll be talking to you about our safety-based estimation of Venice's carrying capacity. That is, the maximum number of people that can fit into the city. My name is Keegan Kuhn.
My name is Nicholas Olson.
My name is Nell Costelli.
And I'm Luke Sandeman.
To go back to what you just saw multiple times, here's a look at the trends of the population in Venice. Here's the residents, of which there's about 60,000 throughout the year. This is a pretty practical graph. You can see it drops on the weekends and major holidays when people leave, also during the summer. It's not perfect. A lot of it's extrapolated from Vodafone to the other providers, but it does a good job of showing the trends. But when we add in the tourists, there's a lot more than there are residents. On average, there's 60% more tourists than residents, and at its worst, there's almost 3 times as many. Now, this causes a lot of problems. There's crowding in the streets, it's hard to get around, and this really irritates the locals. A survey from our sponsor, Professor Bertocchi, of over 6,000 residents and former residents shows that the problem is very well recognized among the people, and a large amount of them think that it's at its worst, super bad crowding. These pictures really show, they really speak for themselves, but they show that the tourists are not appreciated. They're a big problem. As the previous team just mentioned, there's been many attempts at deterrence, most notably the new day tripper tax, but people are just going to keep paying them, especially if it's only €5. They're going to keep coming, and there's no set limit to the number that can come, or numero chiuso, that is a closed number. So now I'll pass it on to Nick, who will talk about the background of our project, which is to find such a number and determine what the maximum number who can fit in the city is.
So while Venice doesn't have a numero chiuso in place, meaning they don't restrict the population right now, there have been studies that have suggested numbers, basically the number of tourists that can be allowed into the city each day. They began in 1988, and they sort of cap off at around 35,000 tourists per day. These were all done with different methods. And then in 2015, one of our very own WPI groups did a safety-based carrying capacity model, basically treating this region between San Marco and Rialto as a stadium. And the exits off of that stadium are the bridges off of that region. So we're using the same standard formula that the 2015 group used, which states that the maximum occupancy is equivalent to the flow rate times the amount of time the evacuation takes times the total egress width. And I'm going to go through each of these and explain what they are in the context of their project and our project. So to avoid panic, the evacuation should, in theory, take 8 minutes. This is part of the European standard, but 8 minutes is also the cap because stampeding might happen after that time. People are crowded together, and they might start to trample over each other. I mean, it can turn into a very dangerous situation. Like, for example, back in 2015, in Saudi Arabia, there was a crush and over 2,400 people were killed. So people trample over each other. There's no clear cause, so people can just start freaking out for no reason. So it's not a good thing. So we want to avoid this. And another part of the standard is the flow rate, which is the 66 people per meter per minute. So we have the 8 minutes times the 66 people per meter per minute, getting us 528 people per minute. And then we're going to multiply by the egress widths of all of the bridges, which the egress width that we're picking for each of the bridges is the limiting width, just because, as you can see in this diagram, people are flowing through. This is essentially the limiting width right here. That restricts the flow overall. So thanks to the work done by a 2013 project group, we have a well-compiled list of each of the bridges and their minimum egress widths. So we have them for each of these bridges in the region that we discussed at the beginning that the 2015 group used. And then we can apply the multiplication by 528, and we can get the capacity of each of these bridges for the 8-minute period. Then if we add that together and extrapolate to the whole city, we get their number of 34,000. So this is 34,000 tourists per day that can be permitted into Venice according to the 2015 model. And there it is. And so Professor Dario Bertocchi, our sponsor, did a tourism carrying capacity model in 2020. And so it wasn't a safety-based approach, but it was more of just looking at the infrastructure of Venice, seeing like, oh, we have this many restaurants that can serve this many meals. Can we sustain like all the tourists that are coming in with the amount of meals that we have? Can we manage the waste that's being generated by these additional tourists? Professor Bertocchi came up with his model, asking questions like that, and he came up with his number of around 52,000 tourists per day. And so we collaborated with Professor Bertocchi to come up with our model and our number, and I'm going to pass it off now to Nell, and yeah, we'll explain how.
So, our project expands off of the 2015 approach. Instead of trying to apply it to a small, densely populated part of the city, we applied it to the entire city. And we started off very small. We started with islands. And the way you do this is you multiply all of the bridge widths by our number for our egress, and we get, for each individual island, a unique number. And we're not doing this to determine the carrying capacity of the whole city. We are doing this to get a good look at what the city looks like right now. So at its minimum, the smallest islands can only hold about 1,200 people. On average, it's about 6,000. And some of the massive islands that connect to a lot of other islands have about 23,000 people as a maximum capacity. Now, what we get out of this is we can identify there are a couple of notable locations. First of all, this island right next to Piazza di Roma and this island right along one of the main roads of Venice are along two major routes that, in the case of short-term evacuations in smaller areas, may result in people getting crushed into a smaller space and panicking. There are other locations like this around here, and around here, that when we do our later calculations, we will find that these are actually some of the major bottlenecks that limit evacuation in this city. So then we take a step forward, we take a step out, and we try to get a general idea of what the number of people is like by doing this same technique on every single sestiere and adding them together. And you can see the breakdown of this here. We get about 152,000 people. Now, when we bring this a step further onto an island level, you're going to get a much lower number of 32,000 people. This is all people, not just residents, not just tourists. But in order to explain how this is the baseline for our final number, I am going to break down how this number works. There are 3 major exits out of Venice. First, the Santa Lucia station in Canareggio. Second, Piazza di Roma leads into Tronchetto, and you can get out by a second bridge there. And then third, there are various boat stops around Venice where you can leave by Vaporetto in the case of an emergency. So we're going to start at Ferrovia at the Santa Lucia train station. The limiting factor is not actually, getting off of this bridge. The limiting factor is getting from anywhere else in the city onto Ferrovia. And the reason is, once you are on Ferrovia, the rate of people coming in is less than the rate of people going out. So our limit is 1,600 people per minute based on the flow rate of all of these bridges. We do the same thing for Piazza di Roma. Again, the limiting factor is getting into Piazza di Roma from somewhere else, not getting from Piazza di Roma out of the city. So we get a number of 1,300 people per minute. With boats, it's a little more complicated. We specifically do not use the boat stops inside of the Grand Canal. The reason is, if all of these boats are operating at maximum capacity, at the same time, they're going to be conflicting with each other, and there is going to be congestion inside the Grand Canal. This is bad. So instead, we specifically identified 24 of 24 boat stops that are around the outsides in important locations and used those as our major exit points. And if all of these are operating at an optimal capacity, you can get 1,100 people per minute out of the boat stops. So if you add that all together, that is 4,000 people per minute can get out of this city at an absolute maximum given like completely optimal conditions. And if you multiply that by 8 minutes, you get 32,000 people. Now I'm going to pass it to Luke to explain why this number doesn't quite work and how we expanded on it to get our final number.
All right, so obviously 8 minutes, can everybody hear me, is too short an evacuation time for an entire city. What we're really trying to do with the 8 minutes here is look at local spots and realize, how do we avoid crowding in any one spot for more than 8 minutes? And so if we look at a local bridge, at a very basic example, let's say you have a bridge where you have one person exiting the bridge per minute and more than one person entering the bridge per minute. Over time, a line is going to form, except in reality, it's not going to be a nice line where everybody waits their turn. It's going to be more like a mob. And so how much crowding is too much crowding? Well, if we use this basic example where we have one person out per minute times 8 minutes, that means in 8 minutes you could get 8 people across the bridge. So if you have that many people already waiting in line to cross the bridge, then the next person is necessarily going to have to wait that long. Except they're not going to be waiting very nicely. They are going to risk having a stampede. And so how many minutes until this happens is how long we can use that bridge with this additional buildup rate. And so if we know the exit capacities of all the bridges, which we get using the egress width that the 2013 group provided, and then the model that the 2015 group provided, and we know how long the bridges need to be operable for, we can figure out the maximum buildup rate before there is a very high risk of a stampede. And we do know that it can take up to 40 minutes to walk across from Santa Elena on this side of the city to the exits of the train station and Frovia. So, therefore, the bridges must operate for 40 minutes. So doing some quick algebra, we can basically come to the conclusion that bottlenecks can allow an entry rate of 20% higher than their exit rate for 40 minutes before there's a high risk of stampedes. And it's really important to note here that this is under ideal circumstances. This doesn't take into account people panicking, people having luggage, having wheelchairs, strollers, other baggage they might have that might get in the way of or clog a bridge, let alone if somebody decides halfway through the bridge that they want to turn around and find a different route, and that's really going to cause a bottleneck. So this is absolute maximum. And so we take this principle and we apply it to bridges using the same rate as before, where we have egress width, 66 people per minute, 8 minutes, and this new crowding factor of 1.2. And we say, for example, with Ponte Academia, you can't have more people than 3,000 people within an 8-minute walking range of this bridge, all trying to use it at the same time, otherwise there'd be crowding. However, obviously there are more than one bridge in the city that would be used at once. So we apply this principle to the entire city using the city exits that Nell mentioned earlier, as well as internal bottlenecks that they alluded to earlier when they talked about specific islands in red. So here you can see the exits are in red, and internal bottlenecks, which I'll talk about more, are in yellow. But basically, applying that same model to the entire city for using the Ferrovia and Piazza della Roma exits, you can get from one chunk to another chunk in 8 minutes, and the number of people who can do that is limited by these bottlenecks. And you might be thinking, well, wouldn't this person just take a boat out? We do take that into account on the next slide. So 8 minutes later, you can see that about 27,000 people who were originally in these regions now are taking the train station and Piazza della Roma out of the city. And additionally, about 6,000 people have been evacuated at a linear rate using the boat stops. And every 8 minutes, this continues, and more people evacuate. Until we get to our final number, where about 104,000 people are able to evacuate through the train station and Piazza Roma, and 44,000 people are able to evacuate during the boat stops during this 40-minute period. Which gets us to our final number of 147 total capacity, which includes the residents. So to get a number for just the tourists, we have to subtract the residents and commuters, which, using the same telephone communication data we had originally, we get a median of 82 residents and commuters. If that 82 number seems high, it's because we also take into account students and seasonal workers who would get priority over tourists. And so once you subtract them, you get 65,000 tourists, day trippers and overnighters, maximum that the city could evacuate. And when you look at our results in comparison to others, it makes sense. They're within the same order of magnitude, and they're a little higher because they really represent the upper limit, the maximum people you could possibly have in the city. It might be lower for a plethora of reasons that we've alluded to earlier, but it definitely isn't any higher than this. And so as our final conclusion, as you could have guessed, Venice needs to reduce the number of tourists. Venice currently has about 100,000 daily tourists, overnighters and day trippers. So if they impose this cap of 65,000 that we're recommending, that would mean about 36,000 fewer tourists per day. And extrapolating annually, if you were to focus this implementation on day trippers, you could argue that this could decrease the annual number of tourists in Venice by 13 million. Thank you.